Okay, welcome to our next lesson on end behavior. This is end behavior part 2, where we actually finally get to determining end behavior. So the last lesson was really vocab heavy. We talked about what is a polynomial, how is a polynomial defined, what is standard form of a polynomial, what is degree of a polynomial, what's the leading coefficient of a polynomial. It's a lot of vocabulary and it's pretty dry. And today we answered the question, why do we care about the degree and the leading coefficient? Because we have to go through all this the vocab stuff to get to, okay, determine the degree and the leading coefficient, both of which are fairly easy to do. But why do we want to do that? Now, the honest answer for a lot of you is you actually don't care about these things. But mathematically speaking, what's the use for it? Mathematically speaking, we do care. And the reason we care so much about the degree and the leading coefficient is because they determine this thing called end behavior, which is going to tell us about what the graph of the polynomial looks like and what it does as x approaches negative infinity and positive infinity. We'll get into that a little bit. It helps us get a picture of the graph. It helps us tell us how the mathematical relationship behaves. And that's why we're interested in it. So I do want to take a moment, and this is a little bit of a deviation from the notes, but I want to talk about what is end behavior. So I can tell you, oh, this is great, degree and leading coefficient determine end behavior, but if you're not really sure about what end behavior is, then that doesn't help you at all. So end behavior, to kind of be a little bit circular in how I defined it, is what the graph does at the end of the graph. Okay, so what does the graph do at its ends? In other words, what does it do when we talk about the ends? We're talking about the extreme left and extreme right. And when we talk about what it does, what we mean is, does it go up or does it go down? So I'll give you a chance to kind of think that through, what the graph does at the ends. In other words, when you look at the extreme left-hand side of the graph, that is left. That's an F there. Left, does the graph go up or does it go down? And when you look at the extreme right, does it go up or does it go down? Now, pictures can often help. We're like big advocates of pictures here in Algebra 2. So we've dealt with, we'll talk about lines, because lines are polynomials. They're degree 1 polynomials. And they're kind of boring, but if you look at the extreme left side of this line, it is pointing down. It is heading down. And if you look at the extreme right, it is pointing up. Now, you could have a line that goes this way, and on this one, the extreme left, be consistent with my colors there, is pointing up, and the extreme right is pointing down. We've also talked a lot about parabolas. So on a parabola, if you look at the extreme, how about I figure out my left and my right? Be better. The extreme left, the parabola is pointing up. If you look at the extreme right, this parabola is always pointing up. And we know we can flip parabolas over, and so you could have both sides of the parabola pointing down. Now, with polynomials, we haven't done other kinds of graphs, but here's the deal with polynomials. Polynomials in the middle, okay, so I'll kind of do like the middle, and then we have the left, and then we have the right. In the middle, polynomials can do all kinds of crazy things, okay? Basically, they just go up and down, and they can go up and down in lots and lots of different ways, but they're going to kind of turn up and then turn down, and they're going to keep turning around. When you get to the extreme right, though, it's going to make up its mind what it wants to do. And the same thing might happen on the extreme left. So eventually, in spite of whatever happens in the middle, a polynomial is eventually going to head up, and it's going to head up forever, or it might head down forever. So if this were the graph of my polynomial, in the middle, it goes bajonkers, okay, which is not a real word, but but when you get over to the left goes down. And so we would describe the end behavior there as the left goes down, and we would say the right goes up. When you're describing end behavior, you do have to indicate whether it is the left-hand side or the right-hand side. Now, most people will do the left first and then the right, because in English we do read from left to right, and that's how most of us have trained our eyes to look at the graph, but not everybody does. Some people actually will state the right first and then the left. So you do need to indicate, for me, I am looking at the left-hand side of the polynomial, or I'm looking at the right-hand side of the polynomial. Okay, now in our study of polynomials, we're not going to go into lots of detail with this, but you could go into lots of details about figuring out how many times the polynomial turns around, how many times it crosses the x-axis. There's a lot you can do with the middle. Today, we're going to focus on the ends, and then we're going to, in future lessons, kind of touch on what we know about the middle of the polynomial. Now, I might go over some of the formal notation for this, how you would express it. So those of you that go to pre-calculus or college algebra, you're going to be familiar with the way that this is expressed mathematically. But for what I'm going to require of you as Algebra 2 students is just simply an answer like this: left down, right up, or like left up, right up, or whatever the answer happens to be. So how on earth does that relate to degree and leading coefficient? Take a moment and copy this chart down. Even if you are following along in class with the notes, even if you're like, well, I'll just bookmark the video, I do want you to copy this down. This is something that you don't want to have to look back in your phone to take a picture of or look at a picture. You want to have this chart. You want to be able to see it. And we're going to reason our way through it. While you're doing that, I'll go and give some background information here. So the reason we care about degree and leading coefficient is because degree and leading coefficient are going to tell us what the ends do. Okay, it's going to tell us what does the left-hand side do and what does the right-hand side do. And I'm going to try to keep this as simple as possible. I have taught this so many different ways. I have taught this with, I've held like all kinds of cans of vegetables in my classroom. I've done what looks like I call it the polynomial hokey pokey, where my fingers like point up and down and you turn yourself around. It's a mess. The last couple of years, though, I've decided to try to explain this by relating it to things that you already know. And if you can tie it into stuff that you already know, then it can help you remember it, because math is consistent and the knowledge should extend. So here's what we care about. The degree can be even or odd. Remember from last class, degree is the highest exponent. And that could be either an odd number or an even number. So you could have degree 4, okay, that would be even, or degree 5, or degree 10, like heaven forbid, we don't want to deal with something like that. Now, degree can never be negative, because if you remember from last class, the degree or the exponents have to be integers. They have to be these positive integers. And so degree can never be negative. So when it comes to degree, you don't have to worry about positive or negative at all, because the degree can't be negative. Degree could be even or odd. Leading coefficient, I'm turning my iPad sideways as though it's going to make a difference for you. Ugh. Sorry, I'm just super demonstrative, and I know my DH class, like you guys don't see my crazy facial expressions and how my arms wave around, but they do. So leading coefficient, I have here on the vertical, and leading coefficient could be positive or negative. We don't care whether leading coefficient is odd or even. That doesn't affect it. So leading coefficient is either positive or negative. Degree is either even or odd. And what you'll see here is that breaks up the possibilities into 4. And the 4 possibilities are that ends could both point up, they could both point down, they could go in different directions like left, up, right, down, or the different directions left, down, right, up. And each one of those is going to go into into one of these boxes. So here's how I'm going to try to explain this to you. We're going to look at the odd and the even, And we're going to relate that to things we already know. So I'm going to click over to the next slide here. And we're going to talk about odd degree. Because you are actually already familiar with odd degree polynomials, namely lines. If you think about lines, lines are y equals mx plus b, where the exponent on the x would be a 1, and 1 is odd. So lines are what we call odd degree polynomials. They're the simplest kind of odd degree polynomials, but because math is consistent, whatever works for lines is also going to work for other odd degree polynomials. So degree 3 or degree 5, 7, 9, you get the idea. So if you can remember what lines do, you don't actually have to remember what anything else does, because lines will do it for you. So think about this. So you have lines, y equals mx plus b. The leading coefficient is m, which is the slope. Okay, I'll let you kind of refresh your memory on lines. This is why knowing lines is so important, because they're odd degree polynomials. So you have the exponent, or the degree, is 1, which makes them odd. And then this number right here is the leading coefficient, and that number is the slope. So picture this. If you have a line with positive slope, it tilts up from left to right. If you have a line with negative slope, it tilts down from left to right. And now you have your end behavior. If the degree is odd and the leading coefficient is positive, then the left is going to point down and the right points up. If the degree is odd and the leading coefficient is negative, then the left points up and the right points down. I'm going to repeat that. We're going to repeat it out loud, and we're going to kind of trace over it, and then we're going to go back and put it on that chart. So if the degree is odd and the leading coefficient is positive, then the left-hand side points down and the right-hand side points up. If the degree is odd and the leading coefficient is negative, then the left-hand side points up and the right-hand side points down. So let's go back to this. I am going to put in here, if the degree is odd, we are going to think line with positive slope. Okay, so what I wrote right there, line with, that's a W, and then this is a plus sign, and then that's the letter M for slope. Line with positive slope. It's going to do something like this. Now, notice that I left this weird little gap in here. Sometimes people will kind of dot in the gap. That's because this is not just true for lines. So when it's lines, you know that it stays the same the whole way through the middle. But remember, polynomials can do all kinds of bizarro stuff in the middle, okay? We don't really know what it's doing in the middle, so we're just going to kind of dash out the middle because we don't exactly know what's happening there. And here's what the end behavior is. The left points down and the right points up. Ta-da! There's your end behavior. Now, for odd degree, remember odd degree, we're going to use lines to help us. And odd degree with a negative leading coefficient is like a line with negative slope. And so because that's kind of messy, that says line with the W / negative sign slope. So that does something like that. And again, I'm going to leave the middle out because we're dealing with not lines per se, but any odd degree polynomial. And so we kind of dot that in, like we don't really know what's happening. And here's your end behavior. The left points up and the right points down. And this is how you would answer the question. You would say left down, right up, or left up, right down. So you identify the degree, identify the leading coefficient, and then if it's odd, you're going to match it up with one of these two boxes. Let's talk about even. Even degree. It just so happens that you are familiar with even degree polynomials because quadratics are degree, how did I put that over here? I just did quadratics. Okay. I just did lines, just we're trying to be consistent. So quadratics, and we spent like months on quadratics, and we talked about the graph and the shape of the graph and how you find the vertex and the x-intercepts and the y-intercept, all that stuff. We spent a lot of time with quadratics. Well, here's the good news. Your quadratics take the form y equals ax squared plus bx plus c. Well, 2 is even, which means that quadratics are even degree polynomials, and a is your leading coefficient. Okay, so how can we leverage what we know about quadratics? You don't have to learn new stuff. This is great. Whatever works for quadratics, because math is consistent, is also going to work for any even degree polynomial. So if it's degree 4, like 2, 4, 6, 8, 10, 12, you get the idea. If you identify that is an even degree polynomial, then I'm actually clapping my hands here. Like, I'm not kidding. I'm very demonstrative. Where was I? If it's even degree polynomial, then whatever works for quadratics is also going to work for those polynomials. The middle might be a little different because the middle is going to get a little messed with, but the end behavior is going to be the same. So here's what we know. If A is positive, there is no flip to your parabola. So your parabola looks like that. And if A is negative, we know that it flips. And we've already studied that. So if A is negative, you have a flipped over parabola. And we've done transformations on parabolas. So all this information kind of comes back together. In this situation here, the left and the right both point up. So we would say left up and right up. In this situation, they both point down. So we would say left down and right down. Ta-da! And there you have it. So if you have an even degree polynomial and the leading coefficient is positive, I want you to think of it as a parabola with no flip in it, which means that both ends are going to point up, and you would write left up, right up. If you have a negative out in front, then you know that it flips the parabola. It flips the parabola over. Sorry, I had to repeat myself. I accidentally paused the recording by messing with my screen. It flips the parabola over, and you end up with the left and the right both pointing down. So let's go back to our chart. If you have an even degree polynomial, I want you to think of that as parabola. I'm going to say para, just for shorthand. If the leading coefficient is positive, we're going to say with no flip. What does it look like? Don't draw that. Okay, what does it look like? It looks like this. Now, as before, I'm leaving the middle out, and that's because it doesn't have to be a parabola. It could be what's called a quartic, that's degree 4. It could be degree 6, degree 8, anything that's even. And if it's a higher degree, then the middle might go weird, okay? Middle might be a little bit weird. So we'll just kind of dot in the middle because we don't know what the middle does, but this we do know. We know that the left is going to point up, and we know that the right is going to point up. And by left and right, we mean the ends. The ends are pointing up. If you have an even degree polynomial, it could be degree 2, like a quadratic, or degree 4, 6, 8. And the leading coefficient is negative, meaning you have a negative out in front, then I want you to think of that as a parabola with a flip, because a negative will flip it over. And so it would look sorry, it would look something like this. And again, I'm leaving that middle out just to allow that it might not actually be a parabola, just the ends will behave. And in this case, the end behavior is left down and right down. So what I'm going to do during the video presentation here is I'm going to pause the video here to allow you time to write down this chart. You definitely want to have this chart written down. You don't want to be, first of all, you're not going to remember it if you just hear this one time. And you don't want to have to be like looking back at a photograph in your phone. So take a moment and write this chart down. Okay, so what kinds of questions would you be asked about this? So we're going to do a couple of examples so I can show you how the questions would be presented and how you would present your answer. And then we'll do a couple of practice and then we'll wrap up this lesson. This is like my least favorite lesson of the entire year to teach, so I'll be glad to wrap it up. And eventually we're going to tie this together with graphing polynomials in a couple of lessons. So here are the two examples, and the directions, like we always want to pay attention to the directions so that we can interpret directions when we're asked to do it on our own. The directions say state the end behavior of these polynomials. So when you're asked to state the end behavior, your answer is going to look something like this. It's going to say left down, right up, or left up, right down, left up, right up, or left down, right down. You're going to answer one of those things. Now it comes to, like, how do you reason it out? Well, that goes back to our last lesson on what are degree and leading coefficient. So when you're asked to determine the end behavior, you have to look at the degree. In this first one, the degree is 5. And what's important about that is it's odd, which means it's going to be like a line, which is odd. Okay, it's going to be like a line. So whatever this does, it's going to behave similarly to a line. The leading coefficient is -4, and what's important about that is that it's negative, and so that's like having a negative slope on your line. Now, I don't typically draw this out because I've been doing this for a bajillion years, okay? And so I don't need to draw it out. But what I would recommend that you do is that on a piece of scrap paper that you would draw a line with negative slope. Actually physically draw it out. So a line with negative slope would look like that. And that's going to tell you your end behavior. So your answer is going to look something like this. You identify the left side and the right side. Your answer is going to be left up and right down. And that is your answer. Okay, and I get craziest answers for this stuff, like up, down, up, down, up, down, down, up, which is, that's not, no. All right, let's look at the next one. So the next one, we have the highest exponent, which is 6. So that is degree 6. And what's important about that is that it's even. Not necessarily that it's 6 per se, but that is an even number, which means it's going to be like a parabola. So whatever the graph of this does, it's going to behave similarly to a parabola. The leading coefficient in this case is 2, and what's important about the 2 is that it is positive, which means there is no flip. So it's this graph, whatever the graph looks like, will behave like a parabola with no flip. Again, I don't typically draw this out, but if I were you and it's the first time I'm doing this, I would draw it out, a parabola with no flip. Okay, so you have the left and the right, and so your answer would be left up and right up. And that's the form your answer will take. You actually do not need to show any work for these at all. You are free to look at the parabola or at the function and immediately state what the end behavior is. You do not have to go through all these steps unless the directions specifically ask you to go through those steps, in which case you do, because you have to follow the directions. But if there are no directions given, you can go straight to the answer as far as you're comfortable. So I'm going to put a couple practice problems up on the next screen, and then that will wrap up this lesson. So here they are. And just as a note, it does say state EB. I will often abbreviate end behavior with the letters EB because who wants to keep writing out end behavior? So we have y equals 3x to the third plus 2x squared minus 4. State the end behavior. And question 2, f of x, just to change it up, equals 2x minus 4x to the fourth plus 1. In class, we might stop at this point and go over them together, but if you hang on in the video, I will explain the solution within the video itself. Okay, so for those of you still with us, here's the reasoning. In the first one, the degree is 3, which is odd. And then I want you to think, okay, odd means it's going to be like a line. Whatever it does, it's going to be like a line. Leading coefficient is also a 3, and the important thing about that is that it is positive. And so you're going to think positive slope. And so positive slope would look something like this. You have your left-hand side here, your right-hand side here, and so your answer would be that the left-hand side is pointing down and the right-hand side is pointing up. And that's the actual answer. What I'm boxing in is the answer. The rest of that is thought process, which you can or cannot write down however you're asked to do it. Second one, let's change the color to orange. Now, this one is a little bit trickier because it's not in standard form. So it goes back to the last lesson with how is degree defined. It's not defined as the exponent on the left. It's defined as the highest exponent, which in this case is a 4. So this one, the degree is 4, which means it is even. And then I want you to think, okay, that's going to be like a parabola because a parabola is an even degree polynomial. The leading coefficient here is a -4, and the important thing about that is that it is negative. Make sure that you do notice that the minus means plus negative. And this means that it is a parabola that would be flipped. So it would look something like that. You have your left side, your right side, and your answer would be something like this. Left goes down, and the right also goes down. Now, as an aside, if you are of the persuasion that you can just photo math this or you can look it up, I can almost guarantee you that it's going to give you an answer that looks something like this. Okay? Okay? I have not taught you that notation. It's completely correct, and I would, expect my college algebra students to understand this, but I haven't taught that to you. So if you start giving me homework or test problems that uses that notation for expressing your end behavior, instead of this way that I have taught it to you, I am going to ask you to explain it. I'm going to ask you to read it out loud so that you can tell me that you know what these symbols mean and what it implies for the end behavior. Because I'm not going to have you guys just copying a bunch of symbols and stuff that you don't understand. So please be aware of that before you start copying stuff that we haven't covered in class. So I'm giving you like a heads up about that. And I know both of these lessons run really long and they're really boring, but we've finally covered it. So we are done with lesson number 2.